Hello everyone, in this video we are going to explore a new topic called as climbing film evaporators. So in this video we are going to focus on principle, construction, working, advantages, disadvantages and applications of climbing film evaporators. Principles of climbing film evaporator. Climbing film evaporators work on three basic principles. The first one is formation of thin film. The second one is rising of the film. And the third one is application of vacuum. The thin film formation. Due to formation of thin film, it allows a rapid heating and evaporation, which in turn also beneficial in case of rapid heat transfer or efficient heat transfer, and reduces the thermal degradation of the products. So it is very beneficial effect in case of heat sensitive materials, that is the materials or the samples which get degraded due to increase in the heat, temperature or heat, and it also provide a large surface area for the evaporation process. Rising of the film. The liquid moves or climbs in a upward direction inside of the tubes due to a drag force which is exerted by the vapor, and this vapor is generated due to boiling process. So this natural circulation increases the heat transfer and separation efficiency. Application of vacuum. Application of vacuum decreases the boiling point of the liquid and make it suitable for concentrating the heat sensitive substances. Meanwhile, it lowers the temperature and prevent the degradation and maintain the product quality. Construction. Climbing film evaporators contains various parts like vapor outlet, cyclone separator and a recirculation pipe, then entry of feed into the tubes, then a pipe is provided for the recirculation of feed, then vapor head, deflector, then a space is provided for the entry of steam between the tubes, then condensate to collect the condensate, then non-condensate gases, then feed inlet, and a receiver for the collection of concentrated product, that is resultant product. Climbing film evaporators usually contain these main parts. The first one is vertical tubes. Vertical tubes are usually they are long narrow tubes. Typically they are about 4 to 7 meters in length and are arranged vertically. These are heated externally by using a steam which is providing a heat source for evaporation process. The next one is vacuum pump. It is used to maintain the partial vacuum inside the evaporator, and it lowers the boiling point of the liquid sample and thereby facilitating the efficient evaporation process. And the next main part is condenser. So condenser condenses the vapor which is coming from the separator back into a liquid. It is an essential part of the evaporation system. Working of climbing film evaporators. Now the sample, or you can say the liquid which is supposed to be concentrated, is introduced into the bottom of the vertical tubes. Means the sample is introduced from the bottom of the vertical tubes through a specialized liquid distributor in order to establish a uniform distribution. And the next thing is film formation. As the liquid enters, it forms a thin film on the inner surface of the tubes. Steam heats the outer surface of the tubes by transferring the heat to the liquid. Boiling and evaporation. The liquid film boils, producing a vapor. The liquid starts boiling by producing a vapor. The rising vapor drags the liquid in a upward direction, creating a climbing film, which is then sent to the separation chamber. Vapor liquid separation. The next one is separation of the vapor and the liquid. So at the top of the device, the vapor and concentrated liquid are separated in a specialized vapor liquid separator, optimizing the separation and collection. Applications of climbing film evaporators. So it is used in various fields. Like first one is food industry. In food industry, it is used to concentrate the fruit juices to increase the sugar concentration and to extend the shelf life. And it is also used in processing milk to produce a condensed milk and extracting soluble solids from the coffee beans to create a coffee extracts. And in the pharmaceutical industry, it is used in concentrating the heat sensitive drugs while preserving their potency and efficacy, extracting active compounds from the herbal materials, and manufacturing injectable solutions. And it is also used in chemical industries, used in processing the chemicals that degrade at high temperatures, solvent recovery to reduce the waste and to improve the sustainability, and to produce in production of polymers and resins. Advantages of climbing film evaporators. The first one is the heat transfer efficiency is very good. That is high heat transfer efficiency. Second one is reduced energy consumption. The consumption of the energy is very less. The third one is suitable for heat sensitive materials. Means suppose the sample is heat sensitive, so it is best suited for the heat sensitive materials. The next one is, that is the fourth one, it operates at low temperatures. And the fifth one is decreases the thermal degradation due to application of vacuum. Here we can use the vacuum so that we can avoid the thermal degradation. And the fifth one is continuous operation. So the process, you can say the operation is continuous. So there is no breaking, or there is no interval between the operation, so that we can use for continuous operation. Then the last one is increased productivity. So we can increase the productive rate here by using the climbing film evaporators. Disadvantages of climbing film evaporators. The first one is in high initial cost. The cost of the equipment is very high, so it is expensive. The next one is expensive to install, and the installation cost is also very high. The third one is difficult to maintain due to its specialized design. Because it is having a specialized design, it is difficult to maintain. And the next one is needs a trained person to operate the equipment. So we require a trained person to operate the equipment. It is not possible to operate by everyone. The next one is difficult to achieve the efficient evaporation in case of the highly viscous liquids. So if the sample is highly viscous, then it is not suitable for this equipment. The next one is, because why it is not suitable means it did not form a uniform film on the inner surface of the tubes. The next one is requires periodic cleaning and maintenance, and difficult to clean because of its complex construction. And finally the last one is periodic cleaning is required.